Hello, welcome to Enlightning. I am so glad you're here. I'm talking to you, the viewer, but also you, Scott Rosenberg. I'm so excited to do this show with you. Tell us about yourself.
Hey, well,
Nice.
extremely excited to be here. Hey, everyone, my name is Scott Rosenberg. I'm a very big fan of the Carvel toolset, and I'm the lead architect in the CTO office at TerraSky, a solutions engineer, a global solutions engineer working in the cloud native space and cloud computing and everything, and here to talk about kapp-controller today.
So excited to have you. We have some hellos from the audience too. Batwan's here and says hi. Hi, Batwan. And Joe
Hey,
says go Scott. So you have some fans already. I love it.
hey, Joe, good to have you here.
There we have Thomas too saying hello. Um, what? So you and I go way back. We were talking beforehand about even just like resources about kapp-controller we might want to share, and and you pulled up a Tanzu Tuesday stream that we did together with some other hosts. I'm gonna put it in the chat right now. So this is Tanzu Tuesday, and what were you talking about in this episode? Oh, are you there, Scott? Uh-oh, we lost you.
That Tuesday was about it was talking about using Carvel kapp-controller as a package manager for Kubernetes and really viewing it as how we can integrate it with Helm, how we can integrate it with existing tool sets to really bring an amazing user experience.
And it was oh, and how long ago was it? Like well over a year, huh? Like maybe a year and a half ago?
I think around a year and a half ago.
It makes me, you asked to share the link and I'm sharing it now, but it makes me feel very vulnerable because of how little I knew at that time. Like I was a little baby deer in the headlights in that video.
Even then, I remember some great questions coming from your side, and
Oh, that's
it's
cool.
amazing to see how you've really through these enlightening shows. It's really awesome to see how the dots start connecting, really, and like the amazing view that you have on things. And sometimes I think coming from the practitioner perspective in these things, I think it's sometimes it is so important. There's a reason I watch every enlightening show. I think
Oh,
it's so important sometimes the perspective of someone who doesn't come in from the 4 years of experience with ABC that knows all the nitty gritty. It's asking the questions that sometimes we forget to ask ourselves.
that means so
Like
much. It
some
is
days,
it feels really
like,
it feels vulnerable to learn out loud, and I'm sure like I rewatch old episodes sometimes, and I like even cringe a little bit at my own questions because there's just so much I didn't know. But it feels okay to do it because of like super kind people like you, Scott, and like people in the chat right now who are like saying yes, this is valuable, please do ask questions, we're not going to make you feel dumb for asking a silly one, where instead we're going to like feel happy that we have your perspective. So because of this community is how I feel like I can make myself so vulnerable. So it's so thank you, Scott.
yeah, one of the most important things that everyone needs to learn how to do, and it makes people feel vulnerable, is say, I don't know, and ask questions about things that they don't know, because everyone doesn't know things, and people are scared to say, I don't know. And it's actually a real inspiration to see you learning live. It's really awesome.
Cool. Thank you. We have some agreement from Lisa, who's here every week. Thank you, Lisa, for being here. And Kormaju, who's a regular and saying that this is his favorite live show. So thank you so much, Kormaju. So that's the past. I think this is the present here in Enlightening. And then you also been a guest on my newest show, which is a collaboration with Victor Farsett called You Choose. So Scott, you're just like a big part of my story. And so it makes it really cool to have you as a guest right now. So
Awesome to be here.
so You Choose is a choose your own adventure style show through the CNCF landscape. So Victor and I will make a decision that moves an application from the developer's laptop through everything, everywhere. But right now in chapter 1 we just wrapped up. We're making a development environment, and one of the choices we needed to make was how to package up that application, or how to configure and define that application. So Scott came on and represented Carvel YTT. And the show we have guests on to represent each technology, and you get only 5 minutes to pitch your technology and why it should get chosen, not win. And then we put then we put it all.
I'll say win because I won.
I was getting to that. So
I
then once,
I really your punchlines.
yeah, totally. So so we have everyone present. We have a Q&A section, and then we put it to a vote on Twitter, like which technology should we use, and then we actually implement that technology in our demonstration that we're building. So Scott represented Carvel YTT, and Carvel YTT won. So honestly, yay! So we'll probably be doing this show for the next couple of years because there's so many system design choices to make. And we'll be using Carvel YTT the whole time because of this episode. So I think it's super cool. Yeah, you were a great guest.
You might as well get used to it because you're going to be seeing Whitney and Victor dealing with it for years to come.
And so we're going to do an episode about GitOps coming up in chapter 2. And so we'll do an episode where kapp-controller is pitted not against everybody's friends. We're holding hands, singing Kumbaya, but where we'll talk about kapp-controller in the context of GitOps, and we'll also have guests on from Argo CD and Flux. And so that will be that You Choose episode. I'll put up a playlist so y'all can see it. And Keith Lee is here. Hello, Keith Lee.
Hey,
Thanks
Keith.
so much for coming. Speaking of GitOps, I would love to hear from chat, like what GitOps tool are you using now? What can be difficult about implementing GitOps? What do you love about GitOps? And then Scott, while I move behind the light board, will you tell me please just generally speaking, some challenges that you see around GitOps?
Yeah, definitely. I really think that GitOps, it's amazing to see how it has really become a standard, right? It's become the standard approach for installing things. The difficulties really come with how we deal with secret management, right? Like, okay, now I have secrets. Well, I can't store those in Git. So number one is how I can deal with that perspective. Another one comes down to credentials. Which is how we deal with the credentials that are going to deploy our application. Does our GitOps controller just have admin access to our cluster and, you YOLO it, you only live once? Or do you, harden down the APIs? It's a really interesting discussion, and it's an interesting debate that exists in the, industry today. And I think the other real big difficulty, I think, when it comes to most GitOps tooling today is really down to the fact that we're trying to bundle together multiple different disparate actions. One is where I'm pulling my source from, the manifests. Another one is how I'm templating those manifests. And the third one is how I'm deploying them. And in the industry today, the typical GitOps tools that exist kind of bake those all three together. And it's, you choose one, right? And you go that way the entire path down. And while for many use cases that can work, it also limits us, right? What I can do in a CLI from just piping from one command to another gives us a lot more flexibility, but that's imperative. It's not what we want. We want to be declarative. We want to work in a GitOps approach. And I think that that's one of the main challenges that we're seeing today is, kind of the rigidness that exists in some of the GitOps tooling in the market.
If there's anything I've learned in my time doing Enlightning and speaking with so many experts, it's that it's always a good idea to decouple things into their smallest possible parts and then compose them That I see that pattern across a lot of different technologies. And so it makes a lot of sense now that we would see it here with GitOps.
Exactly. I mean, it's like, and it always also, a lot of people are always going to go for the, unified tool, that one tool that does everything for them, because that's truly appealing, right? There's a
Mm-hmm.
reason that Helm is the standard tool today used in the market for third-party applications. And really, for a lot of things, it really
The,
is a standard.
the de
And
facto standard, what do you say,
for
Scott?
third-party applications. But yeah, it really is. And one of the reasons for that is because it's so easy, right? It does all three
Uh-huh.
steps. It templates, it deploys, it manages, it upgrades, it does a lot of things in one place. It's a package management solution, it's a templating solution, it's a deployment solution. But that also comes with its, cons, right? Everything has pros and cons. And
Uh-huh.
the Carvel ideology is the Unix philosophy of
Mm-hmm.
one tool that does one thing really well and can integrate well with other tools that do one thing really well. And
Mm-hmm.
that's really, I would say, it's a more difficult to get starting with approach, but
Mm-hmm.
it offers so much more flexibility and so much more in terms of capabilities down the road when you need those advanced use cases.
So will you please tell me again, we repeat, because I was a little distracted. What are the three things you said that GitOps tools kind of do all in one that you want to separate out?
Yeah. So the first one is where I'm fetching my manifests from, right? Where my source is coming from. So call that fetching.
Mm-hmm.
The
Okay.
second one, the second phase is templating, right? We want to template our manifests as that whole episode on You Choose, right? We need to somehow add templating in there.
Mm-hmm.
And the third phase is going to be the actual deployment, how it gets deployed to the cluster.
I got distracted again. Template and deploy. Oh goodness. I think I think I'm gonna restart the whole light board. But I'll still be in this broadcast, but I'm yeah, sorry about this. I try so hard. I like test everything beforehand. I restart everything again after I test it because I really don't want this exact thing to happen live. It it just it I don't know how it knows that this is showtime and then it acts up. But
Yeah.
here we are. So let's just see if that restart works. Thank you for your patience, friends. This is a great time to ask Scott some questions. We have it's Scott Rosenberg, AMA.
Exactly.
Uh-huh.
But no, feel free to ask any questions in the chat here.
Here,
And
Thomas has a comment.
yeah, kapp-controller is so
Mm.
powerful. I get Kubernetes native package management and can build a composable and extensible platform in an efficient and scalable way. I could not put it in better words myself. Maybe you should be on the show and not me. Uh,
Thomas
I
was on Thomas was on last week or customized recently. I'm going to
exactly.
restart, so I'm going to drop off, but you can answer Cormage. I'll be right back.
Yeah, definitely. Right. So yeah, Thomas, completely agree. And Kamaraju, what is the difference between managed cloud DevOps versus GitOps? I think GitOps is a methodology. GitOps is not a tool. GitOps is the idea that Git is going to be my source of truth, right? Now, managed cloud DevOps, right? DevOps, again, a methodology. GitOps is very friendly with the DevOps approach, but they don't contradict one another, but they also aren't the same. GitOps is simply how we define things and where our source of truth is. There are many DevOps approaches that exist today that are not GitOps, that are not with Git as my source of truth. So it really depends, but GitOps is a key part in many managed cloud DevOps style of environments and management. Um, And Lisa said, Scott, tell us about your dog. Does your dog do Kubernetes? So no, my dog does not do Kubernetes. That's Joey. He's one of the cutest dogs. Yeah, I love him and he's awesome. And he's always good to have near me when I'm working or just to hang out with.
So a paradox that that's come since we've been talking about kapp-controller. We're saying it does GitOps and package management. So we're saying it combines these big tools, but then we're also saying it is what's good about it is that it divides your workloads into a lot of small pieces. So this seems like you're saying two opposite things to me.
Like most things good in this world, it's not, one way or the other way. It's not a black and white decision. It's it's all, what is it, 50 Shades of Gray? It's, a bunch of different gray and in the middle, and it's both and neither at the same time.
I love it. I love it. We're getting philosophical with it now.
Exactly.
So for the third time, I'm sorry, will you please tell me the 3 different GitOps things that are happening within one tool that can be separated out from one another?
Yeah. So number 1 is how and from where we fetch our source manifests.
Okay.
Right? So the first step is to fetch our manifests.
Mm-hmm.
The second phase is going to be how we then template manifests, right? So that's going to be a Kubernetes YTT customize to whatever that is.
So templating and patching.
And then we have exactly templating and patching. And then we have deployment, right? How we deploy that newly templated manifests to Kubernetes.
Gotcha. Can we assume the deployment's always going to Kubernetes? Is that an okay assumption?
I think that for this case, the answer is yes. Most GitOps tools typically are working against Kubernetes. Now, that doesn't mean that it's running pods, right? We could be deploying cross-plane compositions that create an RDS instance, but the target that we are focusing on is Kubernetes.
Okay, excellent.
Yeah. So those are really the 3 important steps, and every single person has their idea of what the best tool is for X.
Let's hear it, chat. What's your idea for the best tool for X for each of these things, I suppose? Or prove Scott right. Okay. Cool. And
there's
I wasn't able to follow what you just said because I think your internet connection is bad, unless it's my internet connection, which would be bad. We have
now I'm back.
A question from Kormaju. Oh, great. Is templating patching on containers?
You want to try and answer that one?
Templating and patching is how you're defining your application configuration in a way that can be modified for different environments or for your particular use case. So in templating, templating means you're replacing a configuration value with a placeholder, and then you have a separate values file where you would fill in those values of those placeholders. And then patching means that you would have base files. So I'd say I want these files to be deployed to Kubernetes, but then you could add patches, which would be like small changes you want to make for different environments, for example. And those get overlaid onto your original manifests and don't modify them.
Yep.
How's that? Yeah.
Perfect.
So as far as containers, like containers is when you are running your application, you would reference the application that you want to run in container. So referencing that image is definitely part of what you need to be considering here, because that image is likely to get updated often. That's how it
Right.
relates to
We're not
containers.
actually changing the image, but we may change the reference to what image we are going to run as part of templating.
Yeah, perfect. Go team. Good job, Scott. You and me. All right. Yeah, I'm going to let you control the conversation from here. I feel like what I usually ask at the beginning is what were things like beforehand, but I think you're giving us a lot of context here of why kapp-controller has come into the picture.
Yeah, I mean, it's an interesting thing of what existed before kapp-controller. And I think before we get into that, I think it's important to level set quickly. I know you did a full session on the Carvel tool set, which was awesome with Lee.
With Lee, yes.
Exactly. Who was actually the other person on that Tanzu Tuesday that we did together.
Yeah.
Exactly. But I think it's important just to give a quick overview for anyone that didn't see that session or isn't really familiar with the Carvel tool set. We're really talking in this case about 5 tools from the Carvel tool set that it's good just to level set on so we can use them throughout this, the rest of this session. And the first one that's really important is my favorite one as well, and it's YTT.
YTT.
And YTT stands for YAML templating tool. And its whole job is to template out my YAML. Now, what makes YTT special, you can watch a 5-minute demo where I did not get to the end of my demo, but Whitney cut me off on YouTube. But YTT, the interesting thing that it brings is that it basically brings all of the benefits of Customize and Helm together into one tool. So it allows us to do templating, but it also allows us to do patching. So Customize is a standard tool for doing patching, and Helm is a very common tool used for templating, and YTT offers both. So it's a really powerful tool for templating. The next tool that's really important is Vendir. So Vendir is a really amazing tool that I use daily that basically allows us to define declaratively where I want to pull in things from. What does that mean? I could say, hey, I want to pull down a file from this Git repository. I want to pull down an image from this image registry. I want to pull down a file from this website, right? You can give it a bunch of different types of sources that you want to pull down in a very declarative YAML file. And then once we have a file like that saying, hey, this is the Helm chart I want to pull down, this is the Git configuration I want to pull down, this is the image I want to pull down, we can run a simple command of vendir sync, and that is going to help us sync down to our local machine all of those sources. So no matter where they're coming from, we have a single API for how we can pull down configuration in a declarative and reproducible way.
Cool. So Vendir is like for when you're pulling like third-party things that your app may rely on, or where you're pulling your own container image, like your most updated version, or maybe like other applications within your company that yours might deploy. So all of those things are defined and declared in one place. And
exactly.
And I imagine like which version exactly you want and that sort of thing. Cool.
Exactly. And we get a lock file that, makes sure that it's the same SHA so that we can have it reproducible. And there's a lot of cool things there. And the next tool that's really important is kbuild. So KBLD. And this one was also on YouChoose. and Cora brought this one.
Yeah.
And kbuild really has a bunch of different functionalities. It can help us, again, declaratively define how we want to build a container image. But in the ecosystem of kapp-controller, what kbuild really does for us is it helps us update our manifests, our Kubernetes manifests, which are typically defined with a image tag. And it will replace those with the SHA digest of the image. Now, the reason that that matters is that image tags are mutable. They can change. And just because you pulled down Nginx 1.0.0 today, that does not mean that in 5 minutes from now, when you pull down Nginx 1.0.0, it is going to necessarily be the same image. Because the tag is a floating pointer at something.
Ah.
Right? And when we deal with something like GitOps, when we deal with desired state, we always want to be as exact as humanly possible because we want to make sure that whatever we defined is actually what is getting deployed. I want to know that it is exactly that, and that maybe a bad offender didn't come in, a bad actor didn't come in and override my tag with some malicious image. Right? So
Yeah.
that's another really important tool what kbuild can bring. The next tool, yeah.
So that's not solved by an image signing, because the image signing is what it is you're being looked at as it's pulled. So once you already have it locally, if it got replaced, you might not know because of, is that true? Is it, or is signing an image the same?
Right. So when you sign an image, it
Uh-huh.
actually is signing the SHA digest of that image. It does not sign
Okay.
the tag for that exact same reason, right? Because
Okay.
we want to make sure, again, that we are signing an exact artifact. The way we know that is through the SHA, not through the
Okay.
image. So Co-Sign Notary, all of the tools out there are signing the SHA of the image.
Gotcha.
Yeah. The next tool that's important is image package. It's IMG PKG. We like shortening things in the Carvel world.
I'll say in the whole in cloud native ecosystem. Yes.
Exactly. Luckily, I don't think image package, I don't think anyone is going to try and call it like amgapukba or something like that. So it's not going to be like kubectl or kubectl or kubepuddle. I think we can all agree that it's image package. It's nice to finally have that in one tool in the Kubernetes world where we can all agree on how you say it. But image package is really a great tool that you've talked in the past about on the Enlightning show about the OCI artifacts, right? An OCI format. And so many people think of a container registry as exactly that, a registry that you store containers in. But really, anything can be stored in a OCI compliant registry. So what image package does is it allows us to actually package up our YAML manifests, right? Of our Kubernetes deployments, let's say, together with the images that they reference
that makes so much
into
sense.
a single referenceable artifact in a container registry. What that means is that with one artifact, I can now very easily copy an entire application, all of its manifests, all of its images from one registry to another. Right? If we're in an air-gapped environment, that is a game changer. A single command to move over the entire Bitnami Helm chart repository. Yes, that's in the YouTube video that we talked about, me, Lee, and Whitney. You can get 1,000 Helm charts in a single pull. Done with all the images, relocate them, one command. Yay.
So it has to do with like keeping organized and the ease of getting it, but also in combination with this other stuff, like ensuring everything you get is exactly what you think it is.
Exactly. And allowing us to bundle together everything in
Mm-hmm.
one place.
So
Because,
you have like a snapshot of what's happening, so things don't drift. If something needs to change, you get a whole new snapshot, as opposed to trying to keep track of like the literal thousands of things that could change
right.
between one or another.
It's like,
Okay.
it's also when we talk about a source of truth, right? We want a source of
Uh-huh.
truth. That's the idea of GitOps, right? To have this source of
Mm-hmm.
truth. It's a great idea, except your secrets are usually in Vault or AWS Secrets Manager or some other thing. Now, how do you make sure that everything is in line with one another, that everything is in sync, right? If you're
Uh-huh.
updating certain secret values in a secret management solution and your configuration is in Git and your images are in an image registry, how
Mm-hmm.
do you actually, you have to coordinate between all three of them, that when you're
Mm.
updating in one place, you're also updating the other two accordingly, because otherwise you get drift and you end up with weird situations. Image
Gotcha.
package helps us by bundling it all into one artifact.
So it has a lot of benefits to
Yeah.
that. Cool.
Yeah. And the last tool is
Mm-hmm.
kapp. So KAPP. And kapp is, as I've heard it defined many times, it's kubectl on steroids. And kapp is a tool that accepts any YAML and deploys it to Kubernetes, right? You give it YAML and it deploys it to Kubernetes. Now, the reason that it's called kubectl on steroids is because it adds in so much logic and so many beneficial features that just don't
Mm-hmm.
exist out of the box in kubectl.
Mm-hmm.
So what do I mean by, right? What does that mean, that type of feature that we're getting?
Mm-hmm.
We get ordering of our application, of the deployment, right? We get
Mm-hmm.
a direct order of how things get deployed. When you do a kubectl apply of a deployment, for example, in Kubernetes, it says, hey, created within a second, but your pods aren't
Mm-hmm.
running. Your application
Uh-huh.
isn't ready. But yeah, your desired state, you asked for there to be a deployment in etcd, and there's a deployment in etcd. Kubernetes will do its job.
It's taking all the credit before it did the work, you know?
Exactly. Kapp will wait, right? And that's a nice thing. The other thing that kapp gives us, and this is something also like that Helm does, right? And one of the reasons that Helm really caught on is that Kubernetes does not have a concept of an application. It has a bunch of dispersed resources.
Mm-hmm.
And there's no way of saying, hey, give me all the resources that are part of my application.
Mm-hmm.
That's not a concept that exists in Kubernetes natively. And
Mm-hmm.
what kapp does is it basically maps all of the resources that we deploy in the manifest we pass to it into an application. And then I can run kapp ls, right? List, my applications, and it's going to give me my applications and all of the resources that exist within that.
So kapp groups disparate Kubernetes resources into an application.
Exactly.
Cool.
Awesome. So now
Um,
we've talked about the baseline of the Carvel toolset. Now we can talk about the fun stuff, which
cool.
is putting it
So
all together.
I love it. Before we jump there, let me repeat this back to you to make sure it's a clear picture, since everything relies on this.
Yeah.
um, so we have YTT, which is a YAML templating tool. So it does templating and patching all in one tool. And I know that you can use logic with it too, and it's always YAML. We have vendor, which is you can declaratively define what to pull and where to get it. And so that could be third-party applications. It could be other internal applications that yours depends on. It could be your latest copy of your application. It could probably be, everything I'm saying is an image, but it probably could be other things that are not images too, I imagine. Like an image package, for example, right? And then we have kbuild, which helps update our Kubernetes manifest with the SHA digest of an image, which is important to use SHA digest and not image tags, because image tags could be secretly replaced on you, or they could be changed to point to something else. They're not reliable, but a SHA is what you think it is. And then image package will package up your manifests, which with your SHA images and with the stuff that's been declaratively defined all together. So all of your OCI resources, or regardless of whether they're OCI, all of your resources are packaged together with the YAML that defines them. I actually want to make a quick point. It was when I was a new learner, which was like yesterday, and I maybe still am. YAML manifest means the same as application definition, means the same as application configuration. Like these three, and maybe more, at least these three things are all used interchangeably to mean basically the same thing. And it took me a long time to be able to feel like I could have this conversation. I needed to figure that part out first. So I just want to, for those of you who are new like me, it's all the same thing. So when we say package up the YAML manifest, we're talking about this configuration we're defining. That's a YAML manifest. So package it up together with the images into an OCI compliant package. And then Kapp is kubectl on steroids. So just like kubectl, it accepts YAML and deploys it to Kubernetes, but Kapp adds resource deployment ordering. So for example, a namespace will get created before the resources that go into that namespace. And then it also adds the concept of an application to Kubernetes. So the resources that you deploy together that are meant to work together can all be also associated with one another. And, if you wanted to delete an application, for example, with plain kubectl, it could be hard to chase down all the different resources to make sure you really deleted everything you created. And with Kapp, you would be able to, it sounds like, delete it all easily because they're all associated with one another.
Exactly.
And we have some comments too. Great. So we have Fluffy Sysop says hello. Hi, Fluffy Sysop. Thank you for being here. Thomas says every tutorial explaining how to install some cloud native tool always has 2 steps: apply, manifest, and then wait for deployment. With Kapp, I just run one command and that's all. No need for a second step. Is that because it waits until it's all deployed and then it tells you it's deployed? Okay, great. Exactly. And so with other tutorials, you deploy and then you have to either keep checking to see if it's there, or maybe put up a watch command or something like that. Okay,
or kubectl wait, right? There's like a wait command in kubectl, but it's a separate command. And like there's everything is just multiple steps in
that kubectl. Makes cool. And Deshaun's here. Hello, Deshaun. Thank you so much for coming. Always wonderful to have you. All right. Oh, I didn't remove that. Okay, the foundation is there. So now we have kapp-controller.
Exactly. So maybe it's time that now we define what kapp-controller is. I think that's probably a good idea.
A wonderful idea. Yes, let's do it.
So kapp-controller is a wow. I like to think of a short, concise, and clear way of stating it. Kapp-controller is a GitOps tool and package management solution for Kubernetes.
Oh. Excellent.
Exactly.
Well, this seems like something to feel excited about.
I am.
Yeah.
I love it. Exactly. So that's I think the most concise explanation of what kapp-controller really does, right? And it offers so much in the middle, and that's what we'll get into today.
Excellent. I feel like we've been going a while, and when you say that's what we will get into, it feels like we're also just getting started.
Oh,
I hope I
yeah.
have board space. Cool.
We've only just begun.
All right, bring it.
Awesome. So let's start talking about the, first building block of kapp-controller, which is the app CR. It's the application resource in
Okay.
kapp-controller. And that is a Kubernetes CRD.
So, do you think a good way to frame this is just by for me capturing the different custom resources within Kapp and what they do?
Yeah, I think we'll start with the application, which is the GitOps part, and then we're going to get into
Okay.
package management after that.
Okay. And then is the GitOps part well represented by talking about it in terms of custom resources?
Yeah.
Okay.
Exactly. Yep.
Okay. GitOps part. That's what I'm writing.
Yep.
GitOps parts, custom resources. All right. And the first one you said is an app?
Yep. And that's also the last one.
Oh. All right.
Exactly. For the GitOps part, it's real simple. We have one very important resource, and it's called the application.
It's called app or application?
App.
Okay.
Yeah.
We have some hellos. Hello, Nancy. So glad to have you here. Yay.
Hey, Nancy.
Hello, Findle. Thanks so much for coming, friends.
Hey.
All right. So we have an app custom resource. And what does it do?
Right. So the app custom resource is where we define the three things that were mentioned at the beginning that GitOps thingies need to do.
Right. Where we
fetch, how we template, and how we deploy.
Where we define the following GitOps thingies.
Exactly.
Where we fetch, how we template, and where we deploy.
Exactly.
So what I'm thinking, and tell me if I'm jumping too far, if I'm doing it wrong, because of image package, you only fetch from one place where your image package is. Unlike other GitOps tools, you have to fetch from all over the place. So where we fetch, no, that's not right?
Well, it can be.
Okay.
But what did we say at the beginning? One of the biggest issues is that every tool tries to put these three things together, right? It's you use one thing. In kapp-controller, the idea is we want to give options.
You do you, boo. Yeah.
So you could pull sources down from many different types of locations. You could pull down an image package bundle. You could pull down a file from a random HTTP URL. You could pull down a Git repository. You could pull down a Helm chart. Right? We have the ability to pull from multiple different sources, and that is one of the strengths, right? Through a single API, we can say, hey, you want to pull down from Helm, but want to template using something else? Cool. You want to pull down an image package bundle that includes Helm manifests inside of it, and then template with Helm? You can also do that. Right? We don't want to make decisions. We want to give options.
So where we fetch from anywhere, how we template and fetch using any configuration tool.
Yeah. When it comes to the templating, right? So we define fetching, templating this. The templating, we have 4 main tools that we support today.
Ooh, okay.
So we support YTT. It's the best one. You shouldn't use anything else. Cool. Yeah.
It's been voted. There's been a Twitter vote, so it's very official.
Exactly. It's an official decision. And I do say that, you know, tools win on YouTube. But so there's YTT. We have kbuild, right? Which also does a templating part, right? It's templating our manifests and changing a tag for a SHA. So that's also part of templating. We also have Helm template, right? So we can run a Helm template in order to generate the manifest. We're not deploying with Helm, but we're running basically the templating mechanism of Helm against the manifest.
So it's the Helm template command.
What? It's the Helm template.
Yeah. Gotcha.
Exactly. Another one that we have is Q. So this is Qlang, C-U-E, Lang, L-A-N-G.
L-A-N-G?
L-A-N-G, like language. Yeah.
Okay.
And Qlang is another definition language that exists out there. Like there's YAML and like there's JSON and like there's HCL. There's Q. Some people really like it. Some people don't. But it's another thing, and it's catching a lot of traction out there. And the Carvel engineering team added it into kapp-controller as another mechanism for templating. And the one final one, I forgot there's actually 6, or there's one more.
Okay. I'm listening. Oh, I think you froze.
I'm back.
Okay. Yay. It's
right.
Just an added excitement. Where'd Scott go? Okay.
Yeah. So we have Qlang, right, which we had mentioned. And then we have SOPs. S-O-P-S.
S-O-P-S. Okay.
And SOPs is a project from Mozilla. It's one of their projects. And what SOPs does is, we had mentioned the idea of single point of truth. And when we talk about Kubernetes and GitOps, one of the difficulties that we had said initially is, how do we deal with secrets, right? Where do I store my secrets? I can't just keep my API keys and database passwords inside of Git.
Yeah.
Well, actually, you can, if you do it smartly. And that's what Mozilla SOPs helps with. What Mozilla SOPs does is it's a tool that allows us to encrypt the data within our YAML manifests. And store that encrypted file in Git.
Nice.
And then in our cluster, we just have a secret that's in the cluster with the key that can decrypt it. And we can tell kapp-controller as part of templating, hi, please decrypt using this key.
That makes a lot of sense. I could see how that's solving a big problem. Oh, you're gone, Scott. We also have an example.
I'm back again. Don't know what's happening.
Oh, yeah. It's Zendel picked up as when you said some people don't like Qlang. I like the joke, like, who has 2 thumbs and 1 eye, and fill in the blank, who has 2 thumbs and 1 eye and loves kapp-controller? This girl. Yeah. And then we have Kormaj, who says, where we fetch. What are some examples from that? So I personally think of like OCI compliant image registry. So Docker Hub or Harbor.
So we can pull from there. We can pull down a Helm chart. So basically the Helm pull command, right? We can pull down a Git repository.
Nice.
We can pull down just a file from any web server, just using HTTP, right? And we can also obviously pull down a image package bundle.
Yes.
Yay.
Yay.
Exactly. Now, we've mentioned image package just now in templating. We mentioned YTT. We mentioned kbuild. And in fetching, we said there's a bunch of places that I can fetch from. Well, kapp-controller in the back end is using Vendir in order to pull down all of our configuration. So that is the strength here, right? Kapp-controller is not just another tool. It's actually built using these tools on the left that we had mentioned earlier. Right? So we're using Vendir to pull down whatever configuration it is, and then passing that to templating, where we're using any set of these tools to template, and then we get to the deployment phase. And for deployment, this is the one place where, rightfully so, the Carvel team says, we have the right choice for you. It is the choice, and it is kubectl on steroids, otherwise known as kapp, and that is how it will be deployed. So you can choose how to fetch, from where to fetch. You can choose how to template, what to do as part of that templating. And when it comes to deployment, we pass that off to kapp due to its really strong capabilities and how it really is, in my opinion, the best deployment tool on the market today.
And given that it's called kapp-controller, I think
it makes sense.
Yeah.
Exactly.
I think it's allowed to have that opinion.
Exactly. Yes. Now, the important part about deployment, and this is something that some GitOps tools are good at, some GitOps tools are less good at, is, a lot of times within organizations, we reach sprawl of clusters, right? We have a lot of clusters being deployed. And one of the standard things that we see is the idea of a management cluster, right? I have a cluster where my management components run. And kapp-controller, while it can deploy to my local cluster, the cluster it's running in, we can actually also have kapp-controller deploy to other clusters. We can point the deployment phase at, say, hey, deploy against another cluster. And it's really easy. We just in our map manifest, we just say, hey, the kube config to connect to the cluster you're deploying to is in a secret with this name and this namespace. And it will use that when it goes to deploy your application. So by default, it's going to deploy into your cluster, but it can also deploy to any cluster as long as you give it the kube config to connect to that cluster.
That's cool. And that's Argo CD and Flux would do something like that too. You can point at where
They do it a bit differently. Like everyone does things a bit differently, but it's all basically the same idea. Yeah. Right. And actually, one of the cool things, and this was like back in the day in Tanzu Community Edition, or now in the TKG from VMware, in the commercial offering, they actually deploy kapp-controller onto all of the workload clusters through kapp-controller on the management cluster.
Oh, yeah. Yeah.
Right? So you can reach these interesting levels of, deploying kapp-controller using kapp-controller.
Yeah. And that's actually common across GitOps tools too. Like you use Flux to deploy Flux, you use Argo CD to deploy and watch Argo CD. Yeah. But as you should, yeah. You gotta drink your own champagne. Yes.
Exactly. Now, the important thing to note about the app CR, and this is where some things are different than other tooling as well, is how the security model works, right?
Yeah.
How does kapp-controller actually get the credentials to deploy my application? And the answer to that is very simple.
Yeah.
We define a service account in our app CR. We tell it which service account the app CR is supposed to use when deploying. the reason that is so important is
Mhm.
because we don't have one cluster admin user that everything is being deployed as. Every app, you could use the same service account for multiple applications.
Mhm.
But the best practice is have a service account with its own roles, role bindings, cluster roles, cluster role bindings, whatever it needs, specific to an application that you deploy together with that app. And you create the service account, and then you just reference that within your app CR. That allows us to not need to go back to the days of like Helm version 2, where you had Tiller in the cluster, where you had a server-side component that did all the applying, and it was cluster admin, right? And that was a huge security vulnerability. We have to think of these tools as really least privileged tools. And kapp-controller itself does not have a lot of permissions in the cluster. What the kapp-controller has is the ability to impersonate the service account to run things as the service account that you specify in your application. So nothing runs as that service account. Your application will be deployed with what you define. If it doesn't have the permissions, it can't do it.
That makes a lot of sense. And a service account, for those who don't know, is a way to give an identity to processes, so that you can give them roles and role bindings, like you just said, like you might a person, but you give it to an application or all the different processes, all the different Kubernetes resources in your application.
Exactly. It's like a system user that we used to have back in the day in like Active Directories and whatever, where you'd have a system user that, doesn't belong to any person. It's just a specific process needs to run with credentials. So you generate it, and that's a native Kubernetes construct that we utilize.
So to help increase security, we're making a service account, and each app has its own service account. Each app construct, custom resource has its own service account, as opposed to maybe giving a service account to like the whole GitOps tool.
Exactly.
Right? Yeah,
exactly.
That makes a ton of sense.
Right. So we're really trying to be as secure as possible there to make it work, the best it can, and be as secure as possible and least privilege. Right. That's what matters.
Cool. SA2. That makes a ton of sense. You taught me there's a problem, and then you taught me the solution all at once.
Exactly. Awesome. So that's really the GitOps flow, right? It's a really simple API that, as we see, is very extensible, though, right? Because we can choose how we fetch, we can choose how we template, and having that capability is extremely powerful and allows us to do some really cool things. Like, I actually like to sometimes do a Helm chart where I'll fetch from Helm, I'll template with Helm, but then I'm going to run kbuild because I want the SHAs at the end.
Yeah.
Right? Helm doesn't have that capability. So if you're doing Helm charts, well, you can easily just add kbuild in there, and you're off to the races, and you have SHA digest instead of tags, right? Or you could do a Helm pull, a Helm template, and then run YTT overlays on top of that would make changes that weren't exposed to you in the Helm chart. Because you could run YTT on top of the manifests that were generated by Helm template. We can mix everything together, and that's where we can really get some powerful capabilities.
How complex? I feel like maybe since you're interacting with only one custom resource, it maybe isn't terribly complex to configure, but what's the user experience like? Or
it's really good, actually. It's really good. It's really simple. It's a very clean API, so it's really easy to understand. And yeah, no, I think overall it's a really, really great user experience. But talking about user experience, that's awesome
Mm-hmm.
because that brings us into the next topic after GitOps. Because
Okay.
GitOps in this mechanism, right, where we're
Mm-hmm.
defining where I'm pulling my source from, how I'm templating, and all that, those are low level decisions, right? And
Mm-hmm.
to someone that's building the application, that usually
Yes.
matters, right?
It usually what?
It matters to the person that's building the application,
Uh-huh.
right? But to the end user that's deploying it,
Uh-huh.
it doesn't matter.
Ah. Okay.
Right? The end user that's deploying doesn't care about how you're fetching the manifests or how you're templating it. Those are implementation details.
Yes.
They care about, great, these are the values I need to supply. This is the version of the app I want.
Uh-huh.
Deploy it for me,
Yes.
right?
Yes. Uh-huh.
That's what they should care about. And that's that idea where Helm was the first one on the market that did this and said, we're going to be a package management tool for Kubernetes. So you can define what you want, and
Mm-hmm.
then we're going to allow you to package that. And now a user can deploy it without needing to care about the Helm templating, Go templating stuff that's going on in the backend, right?
Mm-hmm.
So Helm provides us that as a imperative CLI tool. It integrates into other GitOps tools, but it has its way. The idea of kapp-controller is, well, we have this great GitOps mechanism. We have this new declarative way of defining how we want to fetch, how we want to template, and where and how we want to deploy an app. Well, what if we wrap that up and create a package management solution? What if I could wrap up an application as a package and now allow people to deploy my app as a contained unit of a package that I want to give someone?
Wait, so how is that different from Helm?
So the idea of Helm is a
Uh-huh.
client-side tool.
Uh-huh.
Kapp-controller says, hey, I'm a GitOps tool. Why don't we
Uh-huh.
create a server-side package management tool, a
Oh.
Kubernetes side, like within the cluster, right? Instead of it being client-side, let's have a package management tool that's inside of my cluster, that's
Cool.
consistently reconciling, that you get all of those benefits of GitOps for, and we don't have any dependency on the client machine.
So it has a couple it seems like that would be great for air-gapped environments for sure. And
For
then
air and
uh-huh.
for vendor software, for third-party software. Offering a
I don't
solution, let's say, I'm a vendor, I want to give you a solution. I can package it up as a Carvel package, and now
mm-hmm.
you can deploy it easily without caring about the implementation details in the back end.
And with Helm, there's more concern about implementation details.
Well, Helm is only for Helm.
Helm is only for Helm.
That's the issue with it, right? Helm is great. If
Oh,
you did Helm
got you.
templating,
Uh-huh.
great, that's good for you. But what if you
Uh-huh.
needed capabilities of Q, of SOPs, of YTT, of pulling down from
Mm-hmm.
Git, from pulling down from any other source, from bringing multiple sources, getting SHAs? You want more. We don't want to be tied into our templating choice, shouldn't
Mm-hmm.
necessarily affect our packaging mechanism.
So that right now I'm trying to capture the benefits of the fact just that it's server side. And I think what you just said is a benefit in general of the package management
Yeah.
part, and it doesn't have anything to do with the server side piece. So the server side benefits are good for air gapped, and you can use the Kubernetes control loop.
Exactly.
Is there some? Okay.
Those are the main ones.
And then what the next benefit you were just talking about is it's wrapped all into one package, but you still get all of the flexibility that you have in the GitOps part.
Exactly. It's that thing we were talking about at the beginning of decoupling the phases from one another. How I package my application shouldn't be affected by what templating tool I decide to use.
Ah.
Right? And that's why if you look at the title of that Tanzu Tuesday, it was Carvel as the unified package management tool for Kubernetes. Because it's one way to package, no matter what templating and what way of fetching you decide to use.
Okay. Yeah, that makes a ton of sense. Why do I have to use Helm just because I want to package my application?
Right.
Yeah.
Exactly. And that's not, Helm has a bunch of use cases and it's great, but I don't want to be tied in because I chose Helm as my package management solution to, okay, now I have to use Go templating for how I'm going to template my manifests, right? I don't want to be tied in hard that way.
I'll just write unlike Helm.
Exactly.
That makes so much sense. It's hard because like Argo CD and Flux are so ubiquitous. It's hard not to immediately just want to compare. And similarly, because Helm is so ubiquitous, it's hard. Like you almost need to frame the conversation around like, how is this different from what I already know? Yeah.
Exactly. And I think that all of those tools that you mentioned, right? Helm, Argo, Flux, Rancher Fleet, right? There's a bunch of tools out there. They're all amazing tools, right? And they all have their use cases. And I think that Carvel tries to fill a spot that hasn't been solved for, which is this package management part that we're talking about in a GitOps approach. Because Helm does it for me as a, binary. Cool. But we don't get that out of the other GitOps tools. They give us what we just saw before in the app CR, right? They give us that, right? Fetch, template, deploy. But they don't give us a package management solution. So let's talk for a second about the 3 important custom resources that exist in package management, or ideas, right? And their
okay. Before we do, we have a comment from Thomas.
Yeah.
Image package lets you move entire Carvel packages to a private registry in an air-gapped environment with one command. So useful. So is the package management part the same thing as image package?
So the way that you turn an application into a package is by bundling it as a image package bundle.
Okay. Is that what you were getting at when we talked about the 3 important concepts or resources?
Exactly. Right?
Okay.
So if we think about package management and just go for a second back to like our machines, right? Our Linux machines or less so Windows, forget Windows for a second, but Linux or Mac OS or things like that, where we have brew or apt or yum, right? We have these different package management solutions. The first thing you need when you're dealing with a package management solution is a repository. I need a package repository to have packages in, right?
Are these things that you need the same as the 3 important concepts?
Yeah.
Okay.
So number 1 is a package repository.
Okay. You need three things. Here's my top of my cereal. Need three things. One, a repository.
Exactly. Right? So I want to be able to define these packages are part of a repository, right? I want to be able to put a package in a repository that so that my packages are discoverable, right? Because someone should be able to add a repository, like you do a brew tap and you add in a brew repository locally to you, or a Yum repository or an app repository to your machine. And now you have access to that repository's packages.
You want them to be discoverable? Yeah. You want to control access to, discoverable to the right people only.
Exactly, right?
Yeah.
So that's a repository. Then the second one is a package, right? We need some way of defining a package itself. Right? Now, what's important when we define a package? It breaks up into two parts. One is, defining the versions of that package. Right? And so that's really important, that we can have multiple versions of an application. And also, we need to define the metadata about that package, right? You have a package called, whatever, JDK 11, right? The Java Development Kit version 11. Cool. Now, JDK 11 is a version of JDK. JDK it's the Java Development Kit. Now, you have version 11.x, 11.y, 11.z, right? So you have versions within it. Those are all specifics, but JDK is JDK. Doesn't matter what versions you have. Now you need to install a specific version. So we have metadata and versions, right? Those are two parts of a package that matter to us, right?
Okay. So the versions are the versions of the package itself, and the metadata might tell you the versions of the dependencies.
Well, the metadata is going to tell me the overall cross-version basic data about this package.
Okay.
And then every version has its own specifics, right?
Okay.
Every version is that version, but the metadata is that overarching, what is this package? Who created this package, right? What's the link to its URL? Like general data about this application. And then the versions are going to be the implementations of version 1.x, 1.2, 1.3, 1.4, 1.5. Right?
And then the metadata I learned from the Sigstore episode can point at the signed image in the attestation. So that's part of what
exactly.
It can. It doesn't have to. And then can we say that this package is OCI compliant, or in this day and age needs to be OCI compliant?
It typically is. It does not have to be.
Okay.
Yeah.
All right.
So that's a package, right? The next thing we have is a package installation, right? So cool. We have packages. We have a repository. It's got a bunch of packages in it. I need to have a way to install a package.
Yes.
Right? Now, what does that mean in the world of a Kubernetes application, though, that I go to deploy it, right? What that means is, in a package installation, I need to say which package of which version I want to deploy and what values I want to pass into that installation, right? So Helm values, Carvel data values, whatever. It's passing in a values file.
Okay.
And number 4, and the last one, which service account is this going to run as? Because once again, Carvel is secure by default and least privilege. So just like with an app CR, you have to define this, you have to define that in a Carvel package as well.
Nice.
Cool. So those are our 3 concepts. And specifically, I may have given those names for a reason, because corresponding to those 3, we have 3 custom resources that define these 3 exact things.
That makes a lot of sense. Yeah.
We have a package repository custom resource.
So all one word, I imagine, package repository.
Yep. Exactly.
Custom resource.
So a package repository, in the end, if we think about it, what does a package repository need to do? It needs to pull down the packages that are in it to make them discoverable. So if we go back to the GitOps approach that we talked about before, there's fetching, templating, and deploying. The only thing that matters here is fetching. It's not deploying anything to my cluster. It's not templating anything. All it is doing is fetching.
So it pulls down the packages and makes them discoverable.
Exactly.
I like how you're bringing it around full circle, Scott. This is great.
Thank the Carvel team for building such an awesome tool set that just makes sense.
Thank you, Carvel team. Okay.
Exactly.
So this is the fetching.
Just like we had talked about before in the app CR, right, where we have multiple ways of fetching said packages that are part of a repository in this case. Any type of pulling that you can do in an app CR, you can do in a package repository. So you could pull from an image package bundle. That's the typical standard we see. But you could pull from a Git repository if you wanted to. It doesn't matter. It's just fetching packages. So while you can have it in an OCI compliant registry, and that's usually what's done, you could pull it down from Git if you wanted to. I've done that many times.
Okay.
Right? Now, the reason that this is all going to start to really make sense in a second, and when I said just now that the package repository uses the fetch API, right? The fetching, anything you could fetch in an app CR is used in the package repository, right? Anything that you do there. Well, all of the packaging APIs of Kappa built on top of the app. That means that when I deploy a package, in the end, that package is going to create an app CR.
Will you repeat the beginning of that sentence?
Management layer. Yeah. Everything
because
in
you
the
were cutting
package. Okay. Can you hear me now?
I can hear you now.
Awesome. So all of the package management solution of Carvel is a layer on top of the app CR that we talked about before. So when I said that a package repository has that fetch command, the fetch section, just like exists in the app CR, that's because it is that part of an app CR.
Oh. So an app CR references these 3 package management CRs.
Well, the package managements create app CRs to do the work. They're wrappers
Oh.
above it, exposing functionality in a user-friendly way.
So then an app CR is probably going to define one of these three things, but never all three of them.
An app CR is going to define my application from me, right? I'm going to create an app CR for my application. I'm then going to package that as a package. When someone installs that package, in the end, in the back end, an app CR is going to be created for me.
Oh.
So,
and then it'll be still one app CR that reflects all these 3 points and it got that information from these three
it's getting them
custom
all
resources.
The different places.
Oh, cool.
Okay. So we have the package repository. Awesome. What that basically does is it creates for us in our cluster all of the packages, the package resources that are defined within it, right? So it's going to, you can do a kubectl get packages, and you will find the packages that are available to you to install.
So when you say there are 3 custom resources, the next custom resource is a package?
Yep.
Okay.
And this is there's actually 4 custom resources, but we'll talk about one of them very briefly because it is kind of a back-end resource. But we have a package resource. And a package resource is specific to a version of a package.
So your package repository is what's making the package resource.
The package repository is what is applying to our cluster, that is adding to our cluster the package resource.
Cool. So it applies a package resource. Got it. Okay, and now tell me what a package is again, please.
Right. So a package is basically it's a specific version of a application that we have packaged, that we want to expose to our end user.
A specific version of an application that we have packaged.
Exactly. Now, what really matters about this is that the spec of this package, right, when we define them in our repository, what the package looks like, the spec of this is basically the app CR spec. We basically add what we would define as an application custom resource, we define now as a resource called a package. But we add a few other things. So you can say that a package is an app CR with additional data. The additional data that we add is everything that makes it, let's say, user-friendly. What do I mean by that? This is where we have a field that I define the version that this is. I define the clear name of the package. I can define the release notes and what licenses this application contains, right? And one other really important thing.
Was the first one version?
Yep.
And okay.
So version, the name, the author, release notes, right? Any data around this package, right? And then you have one other really important thing, and this is the values schema. And we can define here what that schema is of the values that that an end user can supply me as inputs when they come to install me, right? So on the package itself, I'm saying, hey, these are the inputs that I accept. Right? These are the configuration knobs I'm giving you.
Configuration knobs for user. Knobs. I need to get a new marker just so I have a thinner point. I'm running out of space, guy. This is too good.
Exactly. Carvel is just such a huge thing. It's exactly. But we only have one more resource left, and it's pretty simple to explain in short. So
okay.
Should be good.
So these are the knobs for users. And it's part of the package. Okay. Cool.
Now, the resource that I didn't mention, and we don't need to necessarily have it here on the screen, it's just important to mention so people know. We had talked about the packaging, how there's the defining a version, and then there's the metadata. We have a resource called a package metadata that is just a single resource that many packages are connected to that are all just versions of that. So we have another resource called a package metadata. And then it has a bunch of package resources that are, the actual versions of it. It's just a metadata resource, so it doesn't really matter for our use for, the explanation of the ideas, though.
It seems relevant in the whole, like, breaking things down into their smallest composable pieces. It seems like it's following that methodology. Cool.
Right. And then the final resource that really matters is the package install. And this is, let's say, the end user facing API, right? This is the resource that the end user is going to be deploying to the cluster, because the platform team, whoever manages the Kubernetes cluster, is adding the repositories, and the repository is adding the packages. Well, what matters is I want to now install a package that was exposed to me, right? Hi, I'm Scott. I'm a developer. I'm working on a Kubernetes cluster. I do kubectl get packages. I see what was explained to me, right? I see what was made available to me, and now I want to go and install it.
Yes.
So one of the things that matters when it comes to a package install is that there are two ways of doing it. We can either go down the declarative approach and create the YAML file, right? And really anything in kapp-controller, it has a CLI. And that CLI is called KCTRL, kapp-controller, right? Kapp control. So KCTRL.
KCTRL.
And the reason I mention this now is because Guy Balmas just wrote in the chat that there is a wonderful command there called KCTRL --values schema. And what that does is when you say, hey, kapp-controller, give me the values schema of a specific package, right? I say, hey, give me the values of this package. It will tell you, hey, these are the values that you can supply.
This is what I expect. Yeah.
Right? This is what I allow you to provide me. And that can include the defaults and the options and everything, right? Full descriptions of the values as the author defined in the package itself, right? That's the power here.
Is it defined to the level of like telling you what type it expects, or like
Yep. So it's based off of the Open API v3 schema, right? So you give it an Open API v3 schema, which is the standard for schemas basically today. It's what also is published by Kubernetes for all the Kubernetes APIs and what you define a CRD as. So it's the standard mechanism today for doing this. And you basically
Open
put
API v3.
Exactly.
Cool.
Exactly. So that's our schema mechanism that we're using. And when I run that command, for example, through kctrl, I'll get that value schema in a table format printed out to my terminal in a really nice, easy way, right? Awesome. Now, so what do I define in a package install? Because as mentioned, this is the user-facing, API. So what they define is really, really simple because the developer shouldn't need to care about a lot. What they define here is the reference to the package that they want. So the name of the package, right? So they need to say which package. And they define the version, what version they want. But this is where things get even more powerful. I don't need to say version 1.2. I can give it a version selection saying, hey, you can deploy the latest version that's that's above 1.2 but below 2.0. So any 1.x release, whenever a new one is made available in my cluster, is automatically going to update it.
So there could be logic applied to the package.
The version selection is not hard-coded and make it configurable.
Cool.
Exactly.
I don't know the right words for that. Configurable kind of works, but it doesn't really.
Selection is configurable, I would say. Configurable version selection.
Yeah.
Maybe. I don't know.
Okay.
Yeah. I think that makes sense.
Dynamic. I want dynamic.
Yes.
That's the word I'm searching for. Yeah.
Right? And that's a really strong capability, right? That I can have it auto update within a constraint that I give it. I don't need to, every time a patch release comes out, say, hey, update, hey, update, hey, update. It can do that automatically for me. I can remove that toil for myself. I could also say, hey, only install this specific version because I really care and I want full control. But that we expose to the developer. They can choose.
Okay.
The next thing that we expose here is the values, right? We need to expose a way for the developer to give us values. But we don't let that value in this resource. The values many times are going to contain secrets. They're going to give specifics that are related to them. And we want you to be able to throw a package install in a Git repository, right? And we don't want you to have these issues of how you're going to deal with encrypting data. So what we do instead is have a secret reference. For values, you give us the name of a secret in the namespace that you're installing this into, and that secret contains the data.
So the secret references the whole values file, has the data of the whole values file, not just the secret parts.
Exactly. Because we don't want you to need to say, okay, well, this should be here, and this should be here, and this should be there, and this should be there.
Yeah.
Right? With that being said, you can attach multiple secrets if you so choose. If you want to split your values into multiple secrets, we allow that as well.
Cool.
Okay. So awesome. Once we have that, the final thing that gets defined, well, the final two things, sorry, but one of them is really small, is the sync. One of them is one line.
Okay.
It's the sync period. How often do I want this package install? How often do I want the Kubernetes reconciliation loop to basically run, right?
Okay.
What's the sync period? And that is one of the key values. It's one line that needs to be written, right, on the board here, but it has so much value because that is the difference between this package management and client-side package management of a tool like Helm, where Helm, or if we take Terraform, right, against Crossplane, let's say, right, like, again, the idea of being client-side is that when I apply it, it will make sure that my desired state is what exists. But I don't have that Kubernetes reconciliation loop. Here, the package management solution, my intent is consistently being reconciled at the rate that I define.
That is very important.
Right? And that's the huge part of this. And the last thing they need to say is which service account or which cluster, right, through a kubeconfig secret, they want this installed to. Right? In the end, as mentioned, everything needs to be least privileged. So you give us which service account this is running as.
Which service account and which cluster, right?
Which service account or which cluster. Right? The service account is if it's local within my cluster, and if it's to a remote cluster, we give it the kube config that it's supposed to use. So that it uses the credentials in that kube config.
Got it.
And that's really the idea of Carvel packaging and Carvel GitOps, and really the general overview, I would say, of kapp-controller.
So I want to talk about this through two angles. I want to understand what the experience is of someone who's making a package and wants to distribute it, like packaging up an application and wants to distribute it. What's that user experience feel like? And then what does it feel like to consume an application that's been packaged with kapp-controller? I want to talk about those two things, please. Hopefully there's nothing worth writing down about them.
Exactly, right? Yeah. So when we look at it from the, perspective of the people packaging up something that they want to offer, let's say their end users or their customers, in the end, it is basically generating 3 Kubernetes YAML files and running a single command.
So if I want to package an application, we're talking about packaging, right? I make 3 application files. I make the app, right?
Well, you create 3 manifests, right? You create the package repository manifest.
Okay.
You create a package manifest, and you create a package metadata manifest.
Okay.
That's it.
And that's the one you just mentioned. Okay.
Exactly.
And then if I want to consume an application, I pull it from a registry.
Exactly. You apply the repository manifest to your cluster. That is going to create the package and package metadata resources for you, right? You don't need to deal with them. They get created by the repository. And all you do as a consumer is install that package, install resource.
I love that. So Actually, I do two things if I want to consume. I apply a package repository, and that's something I've pulled from a third party place.
Exactly.
And then I apply that, and then to make an instance of the application, I use a package install and store resource.
Exactly. Now, what's really important to note, though, let's take the community package repository that was built by Tanzu Community Edition and is still publicly available today. Within that package repository, you have Prometheus and Grafana and FluentBit and external DNS and Port Manager and a bunch of packages at a bunch of different versions, all in a single repository. So you can install a repository, and that repository contains within it a bunch of other packages, connected or not, right? That you can then install.
So if I wanted to package up lots of applications together that are meant to work together, I could package it up within one package repository, and it could take one package install to install all of the things that I want.
Well, a package install is for a single package, right? So a package, you would have one package repository with a bunch of packages in it, and then for any package within that repository that you want to install, you would create a dedicated package install.
Okay. But if we wanted our developer experience to be one package install to install several things, then we could do that in how we create our application in the first place to fetch all the other different ones.
You can do that. Actually, VMware have done that in one of their, in one of the commercial products in Tanzu application platform, where there's this idea called a meta package, where a package that a package in the end defines what to fetch, how to template, and how to deploy. Well, no one said that a package can't install a bunch of package installs that themselves will install resources, right? Because a package installs the Kubernetes manifest. So, for example, Tanzu application platform, which is built up of 30 some odd components, and each one is its own package, is actually installed through a single package install that then goes and installs any subset of those 30 package installs, but behind the scenes through magic in the backend.
Cool.
Right? So you could get as funky as you want with how you package things up. You can create a package that includes multiple package repositories, right? You could install package repositories through a package if you so found a need to. I haven't ever found a use case for that.
I love it. Okay, so are you feeling ready for me to try to recap everything that you've said to me? It's been I guess the drinking from a fire hose phrase seems like it really fits today.
I think one thing that I just wanted to mention, because I mentioned it for 1 second, I just wanted to make sure that it's out there so people know as well, is that KCTRL, the CLI that's used here, gives us everything that we've talked about, a YAML manifest for this, a YAML manifest for that, a YAML manifest for this. Everything can be done imperatively through that single command. So you can KCTRL package repository add, give it the URL of the package repository, and it will install it to your cluster. KCTRL packages get will get me the packages, right? We mentioned value schema that Guy had brought up in his comment. KCTRL package install, and that will install a package for me, right? We can do everything imperatively, or we can do it declaratively. So again, meeting the end user where they feel comfortable. If you feel comfortable writing YAML, awesome. If you prefer to run a CLI command, awesome. We got you there too.
If I want to package an app, remind me of what I need the resources I need to make. I want to write that down.
Right. So to package an application, you need, in the end, the package CR, right? You need to create a package YAML that defines where you're pulling from, again, fetching, templating, and deploying, right? It's defining that. It's defining my value schema, and it's defining, right, everything in that package, right? So you're creating a package resource.
Okay.
You're creating a package metadata YAML.
Okay.
And you're creating that package repository YAML.
Okay.
Those are the three things you're building. Right? As the wrapper.
Package repository. Yes. So I only mess with this app resource directly if I'm working with GitOps.
Exactly. You're only dealing with the app resource if you are the one defining how and what is getting deployed and how it's being templated, right? If it's your own application, typically you'll just use the app CR, right? If it's something that you're exposing to end users to deploy, someone that isn't yourself, then you add that packaging APIs around it to make it more accessible to the end user and to not make it so that they need to care about implementation details.
Cool.
So Kamaraju just asked a great question in the chat, which is, does VMware Tanzu build on all of these Carvel tools? And the answer is 100% yes. VMware have, done an amazing job of really building on an awesome portfolio in Tanzu. And actually Carvel, which was started originally as K14S was the name, in Pivotal, which was acquired by VMware, became part of the Tanzu ecosystem, and it was under the Tanzu GitHub organization. And then it was donated by VMware to the CNCF last year in October, I believe. But yes, the Tanzu ecosystem strongly uses the Carvel toolset. And I'd say it's also one of the greatest parts of Tanzu is really this building on top of such a set of tools.
So that was a great question. Thank you. So so if you want to define your own application, you create an app. If you want to package that application, you make a package metadata, and a package repository. And if you want to consume an application that's been created and packaged by someone else, that's when you make a package install.
Exactly.
Excellent. I feel like that's an important thing to capture. I did my best to, it's little and all over the place, but we got it. So please, anyone, I'm going to start doing the recap, but if you have any questions, any great one, like core modules, or even not great ones, we still are. And I want to say hi, a very belated hello to Fuel Stumble. Thank you so much for coming, Fuel Stumble. Fuel Stumble says, are you going to release all of your glass boards as a book? If there are any publishers here today. And Thomas says, such a clear explanation. Thank you.
Awesome.
All right. So while I was having technical difficulty setting up, you were talking about all of the GitOps things. And so these GitOps things have historically been addressed as one big lump. And we're kind of separating them out from one another as part of this conversation. So one thing, when you need to deploy an application, you're going to need to fetch the manifest. So that's like applications that your third-party apps your app might depend on, other internal apps. You're fetching the manifest for the application itself. So where are you fetching all of these things from, and what's your fetching strategy? You're also worried, as part of your GitOps strategy, you're worried about templating and patching, like how are you defining your application with what configuration tools? And you're also worried about your deployment strategy to Kubernetes. So to form the foundation of this conversation, we talked about the Carvel toolset. We talked about 5 relevant composable tools that are part of the toolset. I think there's like 7 or sometimes there's 7 or 9. I don't know. It seems to be growing sometimes. So I'm not sure. But we're talking about these 5 relevant ones. But it's in the ballpark of that number. Are you looking it up now? You seem like you're looking it up now.
There are 8 tools plus a Terraform provider.
Okay, like the Terraform one was the one that was itching the edge of my brain. Like, does it even count? Is it new? So we're talking about 5 of the 8/9 tools here that underscore what kapp-controller is. And kapp-controller itself is one of the Carvel tools.
Exactly.
And the idea with the Carvel tools is the same as the Unix process model, that everyone does its small piece, and then you can use all of the relevant ones together, or you can just use the ones you need. You don't have to have the whole big thing in order to use any part of the functionality. It's all divided up. So, since we're talking a lot this episode of how new I used to be and how green I used to be, I think it was like my second tweet ever. I was learning about Carvel, and I was like, what does it mean that tools are compostable? Like, I totally read. And Cora like gave me the sweetest response. She's like, composable, Whitney. Oh yeah, okay. I love the tweet. Yeah. Anyway, so YTT stands for YAML templating tool, and it's templating and patching all in one tool. With Vendor, you can declaratively define what you want to get from other sources and where to get it, and then it can pull it down and have it locally. And kbuild, it helps you update your Kubernetes manifest with SHA digests of an image, which is important because SHA digests are immutable and you know exactly what image you're getting. If you just have an image tag, the image you're getting could change from underneath you. The latest tag is a great example of that. That could be something different every day. Image package is a Carvel tool that packages up your YAML manifests together with the reference image into one OCI compliant package. So that has security benefits in terms of knowing what's there, but also as teeny tiny things change in your system, it's hard to keep track of all of them. So if you just have a brand new artifact that represents the system that you want running right now, then that's a lot easier to manage. Then we have kapp, which is kubectl on steroids. So you feed kapp YAML and it deploys it to Kubernetes, just like kubectl, but then it adds features like resource deployment orderings. For example, it'll make your namespace before it makes stuff to go into that namespace. It also waits until your application is actually deployed to tell you it's deployed. And then it adds a concept of an application to Kubernetes. So your Kubernetes resources that are all related in an application, it will group them as such, which Kubernetes doesn't do natively. So that's the setting that we've painted to start talking about kapp-controller. Now, kapp-controller has 2 main functions. It's a GitOps tool, and it's also a package manager. So first we talked about the GitOps part. So the GitOps part, we only are concerned with one custom resource, and that is an app custom resource. So if you want to define an application with kapp-controller, you do it with this app resource. And that's going to be not only for this GitOps part, but if you want to make an application that later you'll package and distribute, you still are going to use this app resource. So it's where we define the following GitOps things. So these same GitOps things we talked about up top are being defined in this app resource. So it's like where to fetch everything that you need that's related to your application. Yeah. And then how do we template? There are lots of different templating choices. We talked about Carvel YTT, we talked about kbuild, we talked about Helm, and these aren't mutually exclusive. Probably.
Right. Yeah.
Right. You can use
not. You can
and remind me. Yeah.
Mix and match.
And remind me what's cool about SOPs.
Right. So Mozilla SOPs is a tool that allows us to encrypt our data within a YAML file, store that encrypted file within our Git repository, and then at the templating phase, for example, within kapp-controller, I believe that Flux or Argo, I forgot which one, also supports SOPs. But we can basically have a secret in the cluster with our key that decrypts. And when it's templating, it will actually decrypt that file for us. So that way we can have
So that's
all our
cool.
configuration in one place.
So you could configure it almost completely with Carvel YTT, but then add that soft functionality too as part of your defining your application. And then in this app resource, you're also defining the deployments, which you are forced to deploy with Kapp. In general, you're meant to have as much flexibility as you possibly want. But in this case, you're forced to deploy with Kapp. It is called kapp-controller after all. And then you can point the deployment at a particular cluster. And then you also have the service account is defined at the application level as opposed with other tools where it's defined at the GitOps tool level. And so that would mean you don't need cluster root access. And then you're also only, it just makes a lot more sense about if you want to give, that you would want to give permission at the application level. So let's actually stop here before we get into package management and paint a picture of a GitOps use case. I'm a GitOps practitioner, and I want to deploy and watch this application and have any changes auto reconcile. What does that look like?
Yeah. So one of the typical use cases that we see is that, an app CR will be created that points at, for example, a Git repository. The source is a Git repository, and it will run in the end only a kbuild command. The templating will be kbuild. That repository will include the YAML that I want deployed to Kubernetes, right? Period, end of story. It's the raw YAML. Think of it that someone did a CDK synthesize, or they ran YTT before, or they did a Helm template, whatever it is. The Git repository contains the raw YAML I want deployed. And kapp-controller will come in and watch anything in that Git repository and automatically sync it every minute, 2 minutes, 5 minutes, 10 minutes, whatever I set as its syncing period. And it will automatically deploy that to my cluster. Another very common use case is when we actually do want the templating to happen server side. I don't want to store raw manifests in Git. And this is where a lot of people have started to use the approach that was started in Argo CD, an app of apps, right? That's where this idea of an app of apps started, where what if we have one application that watches our GitOps repository? And in that GitOps repository is where we put a bunch of additional app CRs that are specific to everyone's application. So this one's going to pull down Cert Manager using the Helm chart and then use Helm templating in Kapp to deploy. I'm going to use the Carvel package of Prometheus from Tanzu Community. So I'm going to add a resource of the package install and use YTT to, template that out. I'm going to, we're going to compose every application how it wants to be defined. And that meta application, or that initial, the GitOps application, is going to sync down my app CRs. And each of those in turn then has their own reconciliation where they'll install the applications themselves. So the app of apps helps solve a serious issue that exists in GitOps, where I need to have in my cluster a configuration saying what you're watching, right? The controller needs to know what it's watching. So if I need for every application to imperatively, apply that object to the cluster, then we're losing a GitOps approach, and it becomes much more hard to reproduce later. Our cluster goes down. How do I bring it back up to that same state?
Yeah.
If we use an app of apps, then there's only one resource I'm deploying to the cluster manually. And now everything else is all my other GitOps configuration is being installed also through GitOps.
Yes.
Right?
Super cool.
Yeah.
That was really helpful. So do you feel like we've covered the GitOps portion well? Time to move on to package management? Cool.
Yeah.
So now with the package management part, we talked about how, again, we have server-side package management. So this can be happening inside of the Kubernetes cluster. So therefore, You could use the Kubernetes control loop, and then it's also good for an air gap situation. But basically, your application is wrapped into one package and retains the templating patching tool autonomy. So, Helm's great, it's ubiquitous, but you have to choose Helm Go templating if you want to use the package managing part of Helm only. The only way to do that is with the templating. So now we have a way to package something up, but then choose your mechanism for templating and patching on, have autonomy there. So, so we talked about you need 3 things in order to package your application. You need your repository, and which makes your packages discoverable. You need a package, which is that defines the different versions of your app, and it defines metadata. And then you need a package installation. So in the installation, you say which package, which version, which values, like you need to define the values for your particular instance of the application, and then what service account to run it as, which is maybe sounds like it's different for this than for Helm because of that app level service account feature. So so then we talked about the 4 custom resources that are part of kapp-controller that relate to package management. One is the package repository. So that pulls down the packages and it makes them discoverable. So it's the equivalent of the index.yaml or something in Helm. I forget.
Exactly.
Yeah. And then it applies all the package resources to cluster. So it's relevant to that fetching part of the GitOps things. And then there's a package resource, which is a specific version of an application that we have packaged. So it's an app CR with additional data. So that might be name, release notes, version, author, value schema, that sort of thing. But it has like those knobs for users. But the users don't actually touch the knobs in the package resource. Instead, the user has this package install resource. So the package install resource is the user-facing one, and that's where they actually define the name of the package, the version of the package, which can be dynamically done, the values in the package, which have a schema associated with them, a sync period, which sounds small, but it's actually a big deal because there's a reconciliation loop involved with your package in this case. That's not a part of Helm. I'm sorry, I keep saying Helm. There should be and then service account or cluster is part of what you're defining too. So if you're deploying it to the cluster that your local cluster, you need the service account. If you're deploying it to a remote cluster, you'll have the kube config, which will have the connection details there. So then I think, well, we talked about KC for kapp-controller control is a kapp-controller CLI. And one handy dandy thing we talked about with that is that if you are filling out a package install and you want to know your value schema, you can see that very easily with the kapp-control K. How do you say K-control? Just K-control?
K-control.
K-control. You can use to do that. Cool. And then I think we talked about different things you might want to do and then what custom resources you're concerned with. So we also talked about this package metadata resources where you define the metadata for your package. It's straightforward, but pulled out into its own resource to be true to the Unix process model. So so if you want to just define an application, you do that with an app resource. And if you want to package an application that you've defined, you do that by making a package resource, by making a package metadata resource, and then putting those together with possibly other packages or just solo into a package repository resource. If you're a user who wants to consume a package that's been packaged up by kapp-controller, you would download a package repository resource, and from there you can make a package install to make a particular instance of the package that you want to make that's been applied by the package repository. But then you make a package install resource to make the instance of the application that you want to make. I think that's everything. How do you feel? Yeah.
Feel awesome, right?
Great. Yeah. I feel awesome too.
It seems clear to me. I hope it's clear to other people. So yeah.
I think
that was a
we've
great
had people ask me.
there.
Thanks. It takes you to explain it well to make me recap it well. I feel like it's been great. We've had some great questions as we've gone along, and so I trust people if they have questions. If you do have questions and you watch this recorded version, feel free to put the questions in the comments, and we'll get back to you on it for sure. But this has been a really, yeah.
I will put out one plug here.
Okay.
One of the greatest things about the Carvel toolset, beyond the Carvel toolset itself, is the engineering team behind Carvel are some of the most friendly people that I've met, and one of the most welcoming communities that want to help the end users truly. And I strongly suggest joining the Kubernetes Slack workspace if you're not there. Awesome channels on everything Kubernetes, and there is the Carvel channel there. And all the engineers are in there really looking forward to helping everyone. So any questions you have, difficulties, reach out there. And either community members or the engineers, everyone is there to help. So really recommend it.
Scott's in there. I'm in there. Come say hi. Just say hello.
Just join and say hi.
Yeah. This has been wildly fun. Thank you so much, Scott, and thank you everyone who attended today. Are you ready to dance it out?
Yeah.
Yeah, let's do it.
Why not?
Here you go. Let's see it. Come on.
I don't dance.
Just do this.